5.7. All right, so inequalities in two triangles. The first, we have just two theorems today. The first one is called the Hinge theorem. The other way that you'll hear this one referred to as the side angle side inequality. So what we have is two SAS triangles. And remember what we mean by an SAS triangle. We have two sides and an angle between them. In two SAS triangles, if two sides of one triangle are congruent to two sides of the other, but the angles are not congruent, the larger side is across from the bigger angle. So if we draw a picture, and the picture I think will help us, well, we'll know why we call this the Hinge theorem. So I have two triangles like so, and we're saying that we have these two sides congruent. I need to connect this. And these sides congruent. Call that ABC and XYZ. So we have these two sides congruent to these two sides. What we're saying is if the measure of angle A is greater than the measure of angle X, then this side BC, has to be greater than YZ. And the reason we call it the Hinge theorem is if the door is open wider, we have more room to walk through it. That's what we're saying. So if we have these two sides the same, the angle's bigger, the side across from it is bigger. The door and the doorway are the same size. When the door is wider open, there's more room to walk through the door. All right, questions? All right, so let's look at an example. Let's say, the first one. Are the hands of a clock further apart at 9 or 2? Well, here's 9 o'clock, and there's 2 o'clock. The hands are the same length, so when are they going to be further apart? At 9, because this angle is bigger. Let's look at another one. Here are two triangles. And I have a 90-degree angle here. We'll call that ABC again. And I'm going to say these are congruent. And this is 98 degrees. And we want to know what else can we figure out. Well, we have two sides of this triangle congruent to two sides of this triangle. This is a 90-degree angle and this is a 98-degree angle. So what else do we know? Yeah?
The XZ is greater than AB.
XZ has to be greater than AB. This is a bigger angle. The door is wider open. So we have more room to walk through on this side than we do on that side. All right, questions there? All right, the converse of this is also true. The converse of the Hinge theorem. And that is also called the side-side-side inequality. So the converse of the Hinge theorem says we have two triangles. In two triangles, if two sides of one are congruent to two sides of the other, but the third sides are not congruent, then the larger angle is across from the larger side. And our picture really looks exactly the same. We have two triangles like so. And we're saying that this is congruent to that. Those two are congruent. Call this ABC and XYZ. What this is saying is that if BC, if this side is longer than YZ, then the measure of angle A is greater than the measure of angle X. So the door is open wider, the angle that the door makes with the door frame is bigger. That's what we're saying there. Now we would, both of these things we would prove using an indirect proof. That's why we talked about them after indirect proof. So let me step through it quickly here. So what we'd start with is we assume the opposite of what we're trying to prove. We'd say, assume that the measure of angle A is not greater than the measure of angle X. Assume that they're equal. So if we assume that they're equal, then these two triangles would be congruent by side, angle, side. And we would know that the corresponding parts of congruent triangles are congruent. But that's a contradiction because we said one is bigger than the other. So they can't be equal. So that's a kind of a start on how we would prove. Then we'd also assume that the one is less than the other, and we'd get a contradiction that way as well. So that's just wanted to let you know why we're talking about this after proof by proof, indirect proof. All right, let's take a look at an example with the side-side-side inequality, and then we'll be done. This one is very similar to our opener. So in this triangle, this is 88 degrees, and we have that, and this side is 11. And in this triangle, this side is 7, and this is 4x minus 8. And we want to know what are the possible values for x. Well, we have a side, angle, side triangle here. Side, angle, side triangle here. But this side, this 11 side is bigger than the 7 side. So what do we know about these two angles? Which one, how do those two compare? 88 has to be bigger because it's across from a bigger side. So 88 has to be greater than 4x minus 8. That's going to give us one piece of the information that we need. So I add 8 to both sides. Get 96 is greater than 4x. Divide by 4. And I get that 24 is greater than x. I can turn this around. X is less than 24. So that's one piece. We know x has to be smaller than 24. Well, we have a triangle here, right? In order to have a triangle, this angle has to be bigger than 0. If it's 0, then we don't have a triangle. So I have 4x minus 8 has to be bigger than 0. Otherwise, the one on the right wouldn't be a triangle at all. Well, I add 8 to both sides. 4x is greater than 8. Divide by 4, x has to be greater than 2. So this tells us that x is between 2 and 24. If x is 2, this angle is 0. We don't have a triangle at all. If x is 24, then this 4 times 24 minus 8 equals 88. And those two triangles would be congruent. Those two sides would have to be the same. So x has to be between 2 and 24 for this to work. For this side to be bigger than this side. All right, questions? Okay.